Hi, my name is Tim Piper and I'm here to talk to you about scanning electron microscopes. I don't know if you've ever heard of one. I know I certainly didn't until fairly recently. But they answer a lot of questions like many microscopes do. And so I'd like to cover the differences between microscopes you may be familiar with and what makes the scanning electron microscope different. Well, first of all, if you've ever wanted to know what the inside of a bug's eye looked like, or how the CSI team is able to uncover strange things like the chemical makeup of a piece of carpet, that's probably a scanning electron microscope that helped them get that information. So, if you've seen microscopes, you might think they look like this. And you would be right. That's a typical light microscope. A scanning electron microscope looks very different. What are some of the major differences? Well, they're kind of similar. You can see this is a regular microscope, and you can see there's an optical lens, and then there's a light source down below. A scanning electron microscope is very similar, but it's almost reversed, like that. Why would I want to reverse a microscope? Well, it's kind of the function of how electron microscopes work. You see, with a regular microscope, you use light, and light has a certain wavelength, and we use lenses to magnify that image. Well, because light has a certain length in its wavelength, you can only zoom in so far. What do you do after that? Well, we need something with a much shorter wavelength. So we use an electron. And what the electron does is it allows us to increase our magnification. A scanning electron microscope can examine or magnify up to 1,000,000 times its normal size, which can be very helpful when you're looking for specific information. So, how does it work? Here's a little diagram. Might be a little bit reversed, but essentially what we have is, just like in a microscope where we have light that shines up through the sample, here we have an electron gun that fires electrons down at the sample. When the electrons hit the sample, they bounce off and go into a detector. That detector then goes into a TV. And so how it works is, I have a little diagram. This may be fairly crude. But so as the electrons hit the sample and bounce off and go to the TV, if we have a wide area on the sample, we get a magnified image. If we use the electrons and we narrow that beam so that it's at a pinpoint, the TV is the same size, but the image gets magnified. So that's how we actually get a magnified image on an electron microscope. So what would you use an electron microscope for? Well, you use it for a variety of things. There's that bug's eye. It tells us a lot about form and function and how things go together and why things are the way they are. And a lot of times we take these lessons and we apply them to industrial applications, whether it be looking at a bug's wing to design the plane that'll fly faster or higher or what have you. We also look at things like fabrics and structure. It shows us how to make new products, innovate, how to control quality. We also get to understand more about our world. This is a snowflake. Just like you see in high school or when you cut them out in little pieces of paper, that design was discovered because somebody was able to look at that snowflake very, very closely. And they did it on a scanning electron microscope. There are a bunch of other applications as well on the industrial side. Take, for example, rivets. I've got a picture of a rivet here. Okay? So there's good rivets and there's bad rivets. These are two very old rivets, and a scanning electron microscope was used to analyze these. So what happened is, when they looked at these, they found that when a rivet is made, it's hammered. It's stuck through two pieces of metal, and it's hammered on the end. And if you can see right here, this is where the hammering takes place. But if the metal is bad, then that can cause a structural failure. So they use scanning electron microscopes to look at rivets and make sure there aren't any voids or that the metal is good. Because if the rivet is bad, when an iceberg hits it, it can pop. And as it turns out, that's exactly what happened to the Titanic. And the Titanic went down. And that was just because of poor rivet. Obviously it was an iceberg, but when the iceberg hit it, it was poor rivet quality that ultimately was the point on the boat that failed. Because as that ice pressed into the boat, they sheared off on the inside and it just opened up the side of the boat. So here are some applications where we use scanning electron microscopes to look at, this is a computer chip and this is inside that chip. So we test circuits and we find pathways and make sure that there are no voids. It's used for quality control. We also use it to develop products. So for example, if we look at, this is a cardiac stent up in the upper piece. And down below you can see that this stent has a coating. And on that coating, there needs to be specific amounts. And so they check it with a scanning electron microscope to make sure there isn't too much or too little. So that is some of the applications that we use a scanning electron microscope for. It's a very, very innovative tool. They're not cheap. They can cost anywhere from $150,000 to $1.5 million. And the applications are fairly wide. But by and large, these particular tools are used throughout a variety of different areas. For example, in colleges, they'll use them in the geology department because they can not only tell the shape of rocks, but they can also tell the chemical composition. How this works is that each scanning electron microscope may have more than one detector, or a variety of detectors, and these act as the eyes of the scanning electron microscope. And so by using multiple detectors, we can develop more and more information about what it is that we're looking at. So I hope you've enjoyed this little tutorial on scanning electron microscopes.